Hi there. It's a brief introduction of the ordering system. The ordering system has been very useful in e-commerce websites like the Jingdong, the Wish. So it keeps track of your order from the beginning of placing the order to make a shipment to closing the order. It's also useful in many other applications. Let's say you create a Facebook account, then you register with your email address and you fill the details of yourself. And finally, you select all the interesting content that you like to display. This topic is not anything, it's a new system design topic. So I wrote this letter to you and give an introduction. Uh, this introduction will begin with the workflow, then the data design, and finally the architecture. The story begins from making a deal. The customer and the merchant, they meet face to face. The customer pay the deal, and the merchant will give the product to the customer right away. However, when the transactions are online, the payment and the delivery are not at the same time. For any reputable merchants, they accept the payment like the credit card, and later on when the product is delivered to the customer and the customer acknowledges that they received, and at this time the merchant deduct the amount of money from the credit card, but the customer has to trust the merchant. What if the merchant cannot be trusted? At this time, we need a middleman, a broker, like a market, let's say the eBay and Alibaba. So for the platform, that's the broker who we trust. The customer trusts the broker and pay a deposit to the broker. And in the meantime, the merchant trusts the broker, so the merchant make the shipment to the customer and trust that once the shipment had been received, the broker will pay the merchant. So this is the order. Customer browse the list of the product and decide to buy something. The money is not paid to the merchant, but to the broker. Later on, the merchant sent the product to the customer. The customer received the product by the password generated. Then the merchant started to know the password once it's delivered and use the password to redeem the money from the broker. The workflow can be like this as well. In the very beginning, the customer decide to buy some product from a certain store. How many number of the product, the SKU represents the product ID, and also the received destination. The customer make the prepay to the broker. Broker generates a password for the customer to receive the product. There is a synchronous process, and the merchant will decide if the merchant wants to ship the product or not. If not, we cancel the order. Otherwise, we deliver. It may take days to get delivered to the customer. And once the customer received it, we close this deal. Otherwise, we return money to the customer and return the product to the merchant. This is the sub workflow of the customer. In this workflow, we do not see the parts of the merchant, but this gives us a view what we want to design in our website. So for designing the website for the customer, we notice that it goes through, it transits between among few status of the workflow. At the very beginning, the order is not started. And once the customer click on the UI, say, okay, I want to buy those items of those quantities, it goes into unpaid, not paid status. Once the payment has been made, it goes into the paid. And finally, when the product is received, it goes to the received status. So for keep tracking of the order status, we need the following attributes. Of course, we want the order ID, customer ID. Store ID represents the merchant ID. Is because one merchant can have several stores, and we must know which store the product comes from. And also, the customer choose a list of the products that we want to buy and ship it to a certain destination. The status is the one that defines the status in which which one of the four. But if we design the product using the MySQL, then we normalize the JSON file. Since there is an array, it's quite normal. If we normalize it into two tables, one is the order table, the other is the order product table. The order table has all the contents except for the product. But for the product, it has the SKU, which is the shipment, which is the product ID, and the quantity that the customer wants to buy. And also, very importantly, there is the order ID. The order ID is a foreign key that points to the previous table. Now we have the MySQL as the underlying database. And later on, the UI we wanted to send the REST API, REST request to the service, to the order service. This is the Swagger design. So as you know, the REST support actions like the post, put is the updating, and also the get and the list. This is just the example to create the order. Here we do not have the order ID. It's because the order ID has to be generated by the database, and once all the attributes are sent to the order service, the order service record those persist those data in a MySQL database and return the order ID. So these are the orders. When a customer click make a shipment, it goes into not paid status. And on the new page, or when the user refreshes the page, it goes into the get order. And when the user wants to make any update of the order, or simply wanted to make the payment, then we update the status of the order. And finally, when it's received, we update the status of the order again. The architecture looks like this. The UI is what our customer sees. It sends the REST API to the order service. The order service can be written in Spring Cloud, and it's stateless. All the status persisted in the database. Let's say the order status is in the order table. And when we order a certain number of products, we deduct those quantity from the merchant SKU inventory table. And in the meantime, we send a synchronous notification to the merchant service. Then the merchant service has to decide if the merchant really wants to make a shipment and wait for the payment. Based on this structure, architecture, if we want to support some additional features like making a summary of all the shipment, all the orders of a certain customer, we can make an SQL query. And if the workload is large, it's good to split the data into the read data and the write data, the write database. Like for the transactions, it's good to write in the write database, which is the master node. And also there are the slave nodes, which are the read-only databases. They can synchronize using the bin log. However, when we want to make the queries like this, it's better to read from the read-only database. Overall, we finalized the design of an e-commerce workflow system. We started from describing the temporal workflows, and later on we designed the attributes of the database, of the tables, and finally we come up with this scalable SOA architecture. If you wanna design the similar workflow status, these ideas, the philosophies like making it a status and also keep track of the status and update the status of the workflow. Those can be useful for your future design. Thank you.